welcome Professor Harrick. So good morning to all of you. I think we have heard some really cool presentations on how the world is going to change. I want to probably add a little bit of color of what it takes to actually implement something like this in a real enterprise. So last 4 or 5 years, we've, as part of TCS, we've been actually trying to implement many of these technologies in many of our large customers. These are these Fortune 1000, FTSE 100 type customers. And we've learned a lot of lessons about what is working, what is not working. So I want to give you a little bit of a slightly different flavor about what are the challenges that one encounters when actually implementing some of these technologies within your enterprises. So we've heard about Fourth Industrial Revolution. We call it the digital age. And if you really think about all the types of issues that people have talked about and where AI is being used, you can actually divide them into 4 different levels of sophistication. Right? The first one is basically provide facts. You can call it digitization of the domain, right? Provide facts is the first level. Next level up is provide suggestions by combining facts with some real-time data that is actually coming in, right? So tell you which path to take from going from A to B and which road you should take to minimize your travel time. That's a next level of sophistication. The third level of sophistication is perform a task autonomously, right? So sort of autonomous parking is a good example of that. And then the last one is take complete responsibility for carrying out an activity. Right, so there are 4 different levels of sophistication that one would actually think about. And these things are actually enabling, are happening because of digitization. They are happening, we heard about transforming business processes as we go through, and eventually allowing you to completely reimagine your business. So there are 4 different levels, right? Now, why is this happening right now? We heard some explanation earlier about the fact that now computing has become cheap enough, machine learning algorithms have improved such that they can provide you good quality recommendations, text mining and all of that has evolved. So those are all great reasons for why now. There are 2 other interesting things that are happening. One is what we call dematerialization or software-defined everything. Everything is essentially getting software controlled, software defined. I mean, in IT terms, people talk about software defined compute, storage, network. We talk about software defined everything, software defined services, right? So everything is becoming API-fied. The second thing that is happening is everything is becoming hyper-connected, hyper-instrumented. So as was pointed out by a previous speaker, lots and lots of data is actually there. Sometimes it's not measured, not collected, but now all of that is changing because the cost of instrumenting and connecting every possible thing that you can measure is dropping down to a point where data is basically everywhere. Now, when you combine these trends, the dematerialization, the hyper-connected, hyper-instrumentedness with the compute power and the algorithmic power that is available with machine learning and AI, it is essentially unleashing the power of creating real-time, adaptive, personalized experiences. And you saw some examples of that. And you can come up with many, many, many examples like that. So here is where the challenge comes. When you actually look at your organizations and the way we organize ourselves, the organizational structures, the way teams are organized and so on, the way we run all of this technology and business today is highly manual. In fact, if you look at your organizations, you will find so many layers and silos that have been created that nobody really understands end-to-end of anything that is happening within a large enterprise, right? That's exactly why we create processes. So as somebody talked about earlier, processes will have to simply disappear because of the fact that now an engine essentially allows you to bring everything together. Today, not only do we have lots of layers and silos and lots of manual activities, but it is also because of that, the knowledge about the domain and data is so distributed amongst people that we rely heavily on people to convert observations to recommendations. and actions, right? So usually there is such a long delay between what machine learning can observe to the time it essentially gets converted into a recommendation and action, that usually you are sort of always late by the time you actually perform an action. So it's too slow and too reactive, which is something that has to change as we move forward. So this is a fundamental challenge in truly realizing the potential of machine learning and AI as has been talked about. So as you can imagine, you would say, well, automation needs to be implemented in order to get rid of this lot of manual activity. If you then go and look at how automation is done today in most enterprises, it's not very intelligent. It is very robotic in nature. It takes fixed function procedures, as somebody was pointing out earlier, that you take an operating procedure which is designed to perform a task in a certain way, you essentially encode that and then feed it into an engine. Unfortunately, these kinds of robotic processes work very well if you have a small number of activities that you want to perform using a standardized way, and the approach or the algorithm that you are going to use does not change over time. If you now look at your businesses and your enterprises, you'll realize that both of these assumptions are flawed. First, you have large number of different ways. We heard about 2 different ways of making tea. If I actually add a procedure for making tea in India, it is completely different from all of the above, right? So there are generally hundreds of different ways of doing the same thing in every enterprise, and it's virtually impossible to actually specify or codify everything. Second, the procedures themselves are changing constantly because everything is changing. Underlying technology is changing, regulatory requirements are changing, your workloads are changing, business functionality is changing all the time. So what is true today no longer remains true tomorrow, right? That is where most of these automation approaches fail. On the other hand, you have machine learning and AI techniques that are actually being brought in to infer a lot of insights from a lot of data that businesses are collecting. Unfortunately, most of those solutions tend to not be aware of the business context. So they stop at the level of suggestions, but not get to prescriptions, right? And that's what you need to actually get to in order to convert the power. So what you really need is a combination, which we call intelligent automation. In our terminology, we call it neural automation, which basically allows this automation engine to really think and act like humans without having to specify all different procedures about performing an action. That requires also you to convert from suggestions to prescriptions or recommendations effectively. Now, you heard many examples today, right? We heard many examples of how these things are actually happening in different domains today. There are point solutions that are starting to emerge. But when you start thinking about scaling the benefits of this technology in your enterprise, what we realize is that all of these solutions are actually custom built. What this actually says is that the domain knowledge or rules or properties that govern the property of a domain are highly intertwined with the algorithms underneath the covers. And hence, these solutions are extremely difficult to build, takes an enormous amount of time to build. So going back to the previous speaker, if you really want to see benefits like the ones that are getting projected, you have to figure out how to scale and not take 6 months, 1 year, 18 months to train an engine to perform one task well. Because a typical large business actually performs hundreds, if not thousands of different activities. It is going to be impossible to scale with the methods that we are currently using. In fact, not only are they taking too long, they are actually not very adaptive, because the type of information, structured or unstructured, that your engine or algorithm takes in today would be very different from tomorrow, because you're continuously adding newer sensors and actuators in the system, right? So you have to build these systems that are inherently adaptive. So when you put all these things together, But I want to essentially, perhaps there's one key message that I want you to take away. The problem of scaling AI or machine learning within an enterprise is not really a technology problem. It's a knowledge management problem. Lots and lots of algorithms and techniques are actually there. They will keep improving. The problem is, how do you capture knowledge about an organization or a domain and encode that in a manner that becomes machine processable very easily, right? How do you validate and verify the knowledge? If the use of these techniques stops at providing suggestions, then there is always a human in the loop, and hence, you can essentially rely on the human intellect to fill in the gaps. But as you start doing many more things, as you go from suggestions to prescriptions and prescriptions to actions, the accuracy level has to go up quite significantly, which means you have to start thinking about validating and verifying knowledge that is actually being fed. And last but not the least, how do you operationalize this knowledge automatically while ensuring safety? How do you ensure safety of your environment in the presence of these highly intelligent automation systems that are coming together? Now, if you just stare at this chart for a few minutes, what you realize is that in order for these technologies to become effective and scale within an enterprise, we need to bring the best of AI and machine learning with the best of software engineering. Right? Because in software engineering, we have actually been looking at these types of issues: validation, verification, testing, being able to prove the completeness, coherency of knowledge or programs, as well as essentially ensuring safety. On the other side, you have the best of AI to actually determine how to model a domain, how to capture knowledge about that domain. The only way to accelerate that, so one of the interesting lessons learned for us is that people who understand domain and can describe knowledge are not the people who can actually structure and formalize knowledge. They're completely different sets of people. It's extremely difficult to get a domain expert to talk and teach knowledge in a form that a machine can easily understand. So we have to not only develop techniques that allow us to actually glean knowledge from unstructured data sources, which is already there, but also figure out ways by which you can use crowdsourcing. If you look at some of the examples, there was a Wikipedia example and so on. You can use crowdsourcing as a way to essentially create and curate knowledge. Right? So that's really where the bottleneck is to apply this within most large enterprises. So let me conclude by saying that for these technologies to really shine and scale within large enterprises, we'll have to completely rethink and reimagine how our organizational structures are built and the roles of people. The role of people essentially changes from doing work to, in effect, many times keep the business running or keep lights on or whatever, to creators and curators of knowledge and handlers of exception, right? So the skills that are required to do this are completely different in this new age than what they are today. So this will inherently require a fair bit of reskilling of people within most enterprises. So with that, let me stop. Thank you very much. Just want to mention one thing. So the Ignio platform that we have built actually supports these structured knowledge design, acquisition, and operationalization. There is a booth here. We'd love to have you guys come and visit and have a conversation with us. It's currently being applied for enterprise IT and operations, and essentially it is getting moved up the stack towards business and business operations moving forward.
And a very exciting proposition, Dr. Harrick. We've had the chance to look at it, and obviously Tata and Ignio have been instrumental in shaping the program that you see today. Their approach is very much, let's get practical. Because I think there are two key takeaways that we are hoping to give you through the agenda today, that AI is happening now, and you need to start working on it now. You know, it's convincing you that you need to act, and obviously providing some of the tools with how to act. And Ignio is a great partner in this regard. Are there any questions for Dr. Harrick Vin from the audience? Yes, I can see a few hands. Here you go.
Hello.
Yeah.
You have mentioned the problem of acquiring the knowledge from the domain expert. I know that this is very complex. So how can you approach it from the solution perspective?
There are multiple ways in which you can acquire knowledge, right? So there are unstructured data sources. For example, domain knowledge can be acquired from manuals. So the first thing you do is you feed a manual with a lot of text mining capability within something like an Ignio that actually understands how the context. You have to build a domain model of all the ontology, entities, relationships, attributes, and so on. And a lot of this information actually is embedded inside manuals or books for a particular domain. So you would have to start mining that. Our current experience is that it is not generally the automation or algorithmic solutions are not yet sufficiently powerful enough to leave that learning on its own. So it's usually supervised learning that is required. So and that's where the notion of crowdsourcing actually kicks in, because once you have generated a lot of knowledge. In fact, there are 3 different types of knowledge that you need. There is what is called factual knowledge, which is facts about a domain. There is operational knowledge, which is how do you take actions within an environment. And then there is situational or contextual knowledge. So all these different things have to be essentially acquired, learned, and continuously self-tuned. And there are different techniques that one could use.
Great. Any further questions? Yes, one over there. So we can get the mic over.
Thank you very much for a very interesting talk. So one question I have on this is that as we move towards intelligent systems where we ignore the process and focus on the outcome, for example, as one of the earlier speakers said, one reason we use standardized processes is because we get accountability, clarity, yes, predictability, and we have clear metrics to judge the performance of those systems in the end. As we move towards systems which are essentially more creative in the way they work, won't we need radically new metrics to judge their performance? In other words, won't we have to judge them like human employees, for example, instead of judging them like systems?
Absolutely. In fact, all of these systems, so there are 2 very interesting points that I think I can make in this regard. First, everything has to be 100% auditable, because you need to know exactly what happened. But more importantly, you need to know why the system did what it did. So the ability to provide explanation and evidence in a human understandable way is actually key to the success, because nobody will actually trust these systems to do what you're asking it to do without that level of auditability and explanation, right? In fact, when we have started deploying Ignio in many enterprises, what we are realizing is that building trust with people is perhaps the hardest part of the problem. And tell me what it is going to do before it does it, tell me after it does it, and tell me why it did what it did is actually where a fair bit of challenges exist. So it's not, once again, as I said, it's not a technology problem. It's a problem of being able to convert insights into human understandable explanations, which is where the challenge is. Yeah, it's a question. You can just shout out.
So you talk about scalability of AI, and we look at suggestive turning to prescriptive to actions. Is it not then theoretically inevitable that as one AI system becomes prescriptive, that in turn feeds a subjective into another AI system? So you end up with an AI ecosystem that just becomes faster and faster and evolving, almost like a Moore's law of AI.
Yeah. No, that is very true. And in fact, another point I would make is that you can actually feed suggestive recommendations into a human system. There is no reason to actually not have human in the loop, right? You would actually get human in the loop understand and then continuously feed back into this. So in fact, one of the other lessons that we learned is that any of these systems that we design and build today have to be designed with one key assumption, which is that you never have perfect, correct, or comprehensive knowledge. The day you assume that you have that, all these systems fail. So you need to have ways in which knowledge continuously evolves. You have a way to curate, somebody has to certify, and then it essentially goes back. Only then you can convert recommendations into prescriptions and actions.
Great. Thank you very much again, Dr.
Thank you very much.
Thank you.